Okay, so we have here the example 21 for the node voltage analysis. So like we have mentioned, so the first step to do this node analysis is to um, apply KCL right here in your principal node, which is in this case your node N. So at this point, so as you can see, applying KCL, so current entering is I sub 1 and I sub 2. So current leaving is I sub 3. Okay? So after applying the KCL at the node, so we will make equation for I sub 1. And like we have mentioned, to solve for the I sub 1 or to make formula for I sub 1, so you have to refer to the diagram or the given circuit diagram. So looking at the circuit diagram, so I sub 1 can be solved by using V sub 1 and R sub 1. So using Ohm's law, so V sub 1 over R sub 1. While for the I sub 2 can be solved by using V sub 3 and R sub 3. Okay, so V sub 3 over R sub 3. And for the I sub 3, here is I sub 3. So I sub 3 can be solved using V sub 2 and R sub 2. Okay, now, if you can observe class, both I sub 1 and V sub 1 are unknowns. Okay, so by the help of the node voltage analysis, so we may be able to solve for the values of your voltage drop as well as the current flowing in here. So what is voltage? A node voltage. So as we have learned, node voltage is a voltage from your principal node with respect to your reference node. In this case, our reference node is this G here. So this means that your node voltage is this one right here going here, as well as since this line here or this circuit here is parallel to here. Okay, so they are just the same. These are your node voltage. Okay, so this is this blue one here. This one is your V sub N, as well as here. This is also your V sub N, and this one there. This is also your V sub N. Now, looking here, we may be able to solve first for the V sub N or the value of the node voltage first, so that we may be able to solve for each of the voltage drops. And how to do that? Okay, here's how we will do it. Okay, so we have to determine first the V sub N or the node voltage at this point right here, this one. Okay, so since they are just equal, okay, so we may be able to get the voltage at this point by subtracting V sub A with R sub, or V sub 1 rather, V sub 1. Because as we have learned from the series circuit, right, that if your current is like that, so your voltage will become positive V sub A here, and then when it goes through here in the R sub 1, there will be voltage drop, which is V sub 1, which whatever that value, that will become our voltage right here, right? So this is also equal to your V sub N there. So from here, we can write our V sub 1 as V sub A minus V sub N. Okay, again, this is V sub 1. Now, the same thing we will do at the right side of the circuit. So we may be able to solve for V sub N, the voltage right here at this point, by subtracting V sub B with your V sub 3, this one. Okay, so we may be able to solve for the point here. Again, V sub N is right here from this point to this point. So why do we have to subtract VA with V sub 1, and why do we have to subtract V sub B with V sub 3? Because they are parallel class. Okay, they are parallel and they are just the same. So from here, from this equation, we can solve for V sub 3 by subtracting V sub B minus V sub N. Okay? So, using these values class, we can substitute now it right here from our I sub 1. So, instead of V sub 1, we can use V sub A minus V sub N all over your R sub 1. While for your V sub 3, we can have V sub B minus V sub N all over R sub 3. Now, how about for the V sub 2? Now, looking at the figure, V sub 2 can be what? It is directly equal to your V sub N because class V sub 2 is right here at this point and this point, or it is the voltage across your R sub 2, which is, if you extend, is just the same here. Do you follow? So, we can say that V sub 2 is just equal to your V sub N. So, therefore, our I sub 3 will become V sub N over R sub 2. Do you follow? So, using these values of I sub 1, I sub 2, and I sub 3, we will now apply it here in our equation, which was taken earlier from the application of KCL at your principal node. So, I sub 1 is V sub A minus V sub N over R sub 1 plus your I sub 2, which is V sub B minus V sub N over R sub 3 equals your I sub 3, which is V sub N over your R sub 2. Okay? So, since in our figure, we are given V sub A, V sub B, as well as the resistances, so let us substitute it. V sub A is 58 minus your V sub N. Your R sub 1 is 4. And then plus your V sub B is 10 minus V sub N over R sub 3 is 2 equals V sub N. R sub 2 is 3. Okay? So, as you can see class, our equation now has only one unknown, which is V sub N. Which is, if we solve, we may now be able to determine V sub 1, V sub 2, V sub 3, as well as the currents. Okay? So, using your calculator class, using the shift solve, you can encode this value here to your calculator. And if you click solve or the computation, the value of V sub N will become 18 volts. Okay? So, this value of V sub N, we will be substituting it right here so that we may be able to solve for the voltages. Okay? So, substituting V sub 1 is V sub A minus V sub N. Here. V sub 1 equals V sub A minus V sub N. V sub A is 58 minus 18, so that is 40 volts. While for the V sub 2, we have equals to V sub N, so that is 18 volts. And for the V sub 3, we have V sub B minus V sub N, or that is 10 minus 18, or that is negative 8 volts. Okay? Now, this is already answered. While for our another unknown, which is currents, so using this formula here, we have I sub 1 is V sub 1. V sub 1 here is 40 volts all over your R sub 1, which is 4 ohms. So that is 10 amperes. Okay, while for the I sub 2, we have V sub 3. V sub 3 here is negative 8 volts all over your R sub 3, which is 2 ohms. So this is negative 4 amperes. This is our I sub 2. This is already answered. And for the I sub 3, lastly, we have V sub 2, which is 18 volts, while your R sub 2 is 4 ohms. And that is 6. Is it correct? Yeah, 6 amperes. And there you go. So we have there the voltages as well as the current. So So class, again, this is the node voltage analysis, which helped us in solving the unknowns in the circuit. So in this method, we showed how to first solve the node voltage in that given circuit. Okay, but class, node voltage is just another method. Okay, you can use other method in solving for the unknowns here, just like the mesh current. Okay, you can solve this by using the mesh current, but in this certain problem, you are asked to solve for the node voltage analysis, so therefore, you have to use the node voltage. And that's it.